Hi, I'm Dave, KG0ZZ. I've been a licensed amateur radio operator since 1993, and my favorite part of the hobby is building antennas. Today I'd like to show you how to build a simple 4-element Yagi antenna to work the 2-meter band. Now this antenna is a little bit different than the last one that I built. The last antenna had a dipole driven element, and in this antenna we're going to use a gamma match. Now I have all of my parts gathered. I'm using an old TV antenna, and again we're going to convert an old TV antenna into a ham radio antenna. This is a section of TV antenna boom that is about 42 inches long. The spacing between the insulators is 12 3/8 of an inch, and I think I'm just going to go ahead and drill these out and go with the spacing that's already here, and so they'll be equally spaced, and I don't think we'll have any problem with that. We have VHF elements for our elements to build the antenna with. I've got 4, and the longest element is going to be over 40 inches long, so you'll need elements that are long enough to be one solid element all the way through. And then another half an piece of tubing for the gamma match. And to build the antenna, you're also going to need a feed point connector, and you can use either an SO239 chassis mount connector, or what I'm going to try to use probably is a bulkhead type connector. This is just a little bit different. It has a nut that screws down on the inside of it and has a washer. And so this, you would also need some mounting hardware to go along with that. And this, you just simply drill a hole and tighten the nut. You're also going to need a piece of RG8 cable, the same as your coaxial cable. You're going to need a piece that's at least 1 foot long, and you'll need to remove the outer jacket and remove the outer braid, leaving the dielectric and the center intact. We have the UHF section of part of a TV antenna, and I'm going to use the clips off of this like I did in the last antenna. That worked out really well. Those really helped hold the elements on the boom nice and snug. So I'm going to rob the clips off of that. You're also going to need a mounting bracket. And this is a clip that came off of here, and I'm going to try to use it for a mounting bracket for my feed point connector. And this is also where we're going to attach our gamma match. Now, to tune the gamma match, we're going to need a proper length of coaxial cable. I'm shooting for a frequency of 145 megahertz, and so I've tuned this length of cable so that it's resonant at 145 megahertz. This piece of cable is 38 feet 2 5/8 inches, or about 11.649 meters, and that works out to about 29 1/4 electrical wavelengths. Also, off of the last TV antenna, we have this aluminum strap. We're going to need that to help make our gamma match. I'm going to see if I can flatten that out and make that into a connecting bracket for the gamma rod. And these elements really need cleaned up. They're kind of gray on one side. Some of the gold coating is still on the other side. But I also have some steel wool, and I'm going to use it to clean up the elements with. These will be bright and shiny by the time we're finished with them. So that's it. That's all the parts that we need. If you don't have an old TV antenna, this is just 1-inch aluminum, 1-inch square aluminum, and the tubing you would buy 3/8 inch, and the aluminum that you really want for antenna elements is T6061, Tango 6061 aluminum. When we clean this up, I'm going to leave that sticker on there, and that's a reminder. And please be careful when installing antennas never install them near power lines, and always disconnect them before the storm arrives. So I'll take the boom and we'll start drilling out the pop rivets, and I'll get that all ready to go. I'll get these cleaned up and get them cut to length, and we'll go from there. We're over at the workbench now, and I'm getting my parts all ready to go. I've got my elements all cut to length. I'll just go ahead and give you the measurements for these. My reflector is 40 and 13/16 of an inch, or 103.7 centimeters. The driven element is 38 and 15/16 of an inch, or 98.9 centimeters. My first director is 36 and 1/8 of an inch, or 91.8 centimeters, and the second director is 35 and 7/8 of an inch, or 91.1 centimeters. So our elements are going to go on the boom just like the last antenna. I've saved the clips off of the UHF sections, and we're going to attach each of the elements with a clip, and use a number 10 machine screw, and fasten them to the side of the boom, and they all go on the same way. Now the boom, I cut off the ragged edge off here, and I've drilled holes for the mounting bracket, and there are I drilled two sets of mounting holes in this antenna, and there's two different ways you can do this. What I've done is where I cut off the ragged edge, I just left it a little bit long, and I drilled out holes for the mounting bracket, and these are on the same side. Here at the end, these are on the same size as the mounting holes for the elements, and so this is for using the antenna vertically. The antenna is short. This boom turned out to be 41 and 3/8 of an inch long, or about 106 centimeters, and so it's about a half a wavelength long. So if I wanted to use this for a vertical antenna, I would probably put the clamp right back here in the back, and extend my coax back here towards the reflector, and mount it like this. This way the vertical mast does not interfere with the radiation pattern of the elements. Then I've also drilled a set of holes in the middle of the boom, and they're on the opposite side, and that would be for mounting the antenna horizontally. When the antenna is in a horizontal position, the vertical element is not noticed as much by the radiating elements. So that's the boom. Also, you're going to need a piece of tubing that is 11 inches long, and this is for our gamma match. And then what I've done with this is a piece of RG8 cable with the jacket and the shield removed, and this section of dielectric is 11 inches long, the same size as the tube for our gamma match. And I said to make you need a piece at least 12 inches long. I've made mine 2 inches or 1 inch longer. I've made it 13 inches long, so I have 2 inches of wire here and 11 inches of dielectric with the wire. And when you put this together like this, that becomes our capacitor for our gamma match. The wire on the inside acts as one plate, and the tubing on the outside of the gamma match acts as the outer plate, and so the dielectric in the center is a spacer to keep it evenly spaced, keep the two plates evenly spaced, and this becomes our capacitor for our matching network. Now, the feed point, what I've done is I've taken one of these clips for the antenna elements, and I've just stuck it in the vise and flattened it out, and there was already a crease in the bracket, so what I did was I just flattened this out in the bench vise, bent it over, gave it a couple of taps with a plastic mallet, and made an angle bracket. And this just happens to have the pin line up with the hole in the mounting bracket, and I think I'm going to skip using some extra hardware, and I'm just going to use the same machine screw that I used for the element to hold this into position on the boom. Now my pin from the edge of the boom to the pin, it's not quite an inch, it's about 15/16 of an inch. Now what we'll do is, let me show you how this gamma match will mount on the antenna, and what we're going to have to do next here.